Thank y'all for attending today. What we're going to talk to you about is on-site sewage treatment systems. I'm going to go over some maintenance, and for that I'm pulling a lot of information from some presentations I did along with the help of the Louisiana Department of Health. We're not going to go so much into the permitting side as far as DEQ is concerned, like getting into the nitty-gritty of effluent limitations and that kind of stuff, but I am going to talk about it. But instead, we're going to focus more on sewage and what it can do to the environment and to human health, and some ways to make sure that does not happen, that it does not become an issue. So that's kind of the slant that I'm taking on this thing. And for my presentation, we're going to start off and basically real basic stuff, because I want to design this so that anybody can come off the street and just kind of get a good understanding of what's going on with a home sewage treatment system, or a sewage treatment system if they have a business or something like that. So we're going to define what sewage is. We're going to define and identify on-site sewage treatment systems. I'm going to go through their maintenance and regulations. And again, I'm going to be really relying heavily on some stuff I've got from the Department of Health. We're going to go through the environmental and health effects of sewage, how to identify system failures, and then look at the benefits of treating, benefits of maintenance, and basically what that means to you, for both you around your house and for the environment. So just as a definition of what sewage is, you'll also hear the term sanitary. You hear sanitary sewage all the time. It's basically all human and or domestic waste, and it's basically in the form of liquid and solids. That's how it's moved around, and it comes from the toilet, the bath, the laundry, the lavatory, kitchen sink, and those kind of wastes. Now, as I'm talking, I want you to look at this picture at the bottom, and it gives you a good idea of where the different types of sewage comes from. Sewage is basically divided into black water and gray water. Those are the two different types of sewage. And black water is basically from the toilet, and then gray water is basically from everything else. So your washing machines, your dishwashers, your showers, and any kind of drain. The thing to remember out of this slide is that black water and gray water can both carry disease, and as such, it is required by the sanitary code with the Department of Health that they all are treated. So just as a good example, I just noticed a month or two ago, my neighbor, actually, I live in St. Francisville in a town that has community sewage systems. We have our own system, our community system, so I don't have to worry about maintenance myself. My neighbor is actually hooked up to the community sewage as well, but for some reason, somebody ran a line out from his kitchen sink out to the ditch. So that's actually an illegal hookup. You can't do that. It all has to be connected to the city sewer. So don't go telling on my neighbor. Eventually I'll have to deal with it, but just as an example, you can't do that kind of thing. I put in here that a lot of indoor water use equals sewage, and let me kind of explain what I'm talking about. But first off, you see USGS, the United States Geological Survey. They did a study that estimated that the people's use indoors in their house is 80 to 100 gallons per day. Now, to me, I can't picture myself using 100 gallons per day of water in a given day. But I think what they did, they averaged it out through all the study, through all the people, through all the days of use. And quite frankly, that's quite a lot of water. And when you think about it, we all use water every day, not just indoors, but outdoors. I actually, for example, I have a cotton t-shirt on, and this t-shirt, made out of cotton, it takes water to grow cotton. One thing that I do is I do courses or presentations to like small children or school-age children, and we actually talk about a hamburger and break that down into the different components of a hamburger back to where water would be involved in the process of getting those different components. And it really opens up their mind and opens up their eyes to like, yes, water affects us every single day of our life. We use a lot of it. We need it. We can't live without it. All the indoor use, washing, flushing the toilet, any kind of cleaning you're doing, in a roundabout way, eventually ends up down a drain at some point. most of it, not all of it, but most of it, which equals sewage. So we got to do something with all this waste. And indoor water use can be broken down into these components. The most common you see is the toilet. 25% of, at least in this study, it was 25% of indoor water use was from flushing the toilet. Clothes washer, that was 22%. The shower was 17%, and then faucets, and then see leaks, 14%. Think about that. That's a lot of water just going down the drain for nothing. It's a waste of money, especially if you're in an area that has issue with groundwater and falling groundwater levels. That's a direct influence on your groundwater levels, for example. So take care of your leaks. So let's define an on-site sewage treatment system next. I'm going to just read this definition. Any system used to collect, transport, pump, treat, and or dispose of sanitary sewage, and which is located on the property where the sewage originates. So think about it like this. You have a property, your own place, and you have your own sewage treatment system that treats anything comes out of your place. These are the types of systems that we're talking about, like a house, a single family dwelling, not an apartment complex, but a single family dwelling, a camp, or any type of business, could be a church, any place that treats its own sewage and is not connected to a community or more centralized or a city sewer system. So that's the only ones that we're talking about in this presentation. So let's go over sewage treatment. And in a sense, this can actually convey to all wastewater treatment for the most part, but we're focusing on sewage. There are three basic components of sewage treatment. Primary treatment, which basically is the physical separation to take out the solids. Secondary treatment, which is the biological processes that remove dissolved inorganic compounds. Now that we're talking about, the bacteria is actually eating up the pathogens and the compounds, and their waste turns into gas and liquid, and that's what breaks down the solids in whatever waste stream. And for us, we're talking about sewage. And then disinfection. That's basically killing all the pathogenic organisms, or a certain percentage of the pathogenic organisms at the very end of whatever sewage treatment system you were using. So this is actually a schematic just to show primary treatment. It's not actually an actual sewage treatment system. Just kind of shows the methods. Some places or some systems will actually have a screen. So you see on the left, the influent comes in, for example, sewage from a home or a business, and there could be a screen that catches whatever bigger chunks or bigger objects could have been flushed down the toilet or whatever. Then there could be a chamber after that, or there is a chamber at some point where the larger solids will fall out to the bottom by gravity. And what happens is the water gets into that chamber, and when it slows down, the heavier solids fall out of it. Then in this schematic, the water keeps on going, and there's another chamber where the lighter solids, after the water calms down a little bit, slows down its flow, the lighter solids fall out to that, and it makes a sludge layer at the bottom of it. And then the effluent flows on out. So that's physically removing the solids either through some kind of a screen or just by gravity, basically. And that's primary treatment. Secondary treatment, again, is using biological processes. And it could be, like this one is aeration. We call it aerobic treatment. Basically provide air to the influent as it comes in this aeration tank. And that gets the bacteria that likes the oxygen activated. It gets them active. And as they're eating up the other bacteria, that's what's reducing all the solids and the different pathogens within that waste stream. Then the water flows out into a secondary tank. The more clear water will flow on out as effluent to a discharge, or the stuff with more solids in it, and the active solids or the heavier stuff will actually go down to the bottom and returned back to the aeration tank to be reprocessed again. Now this is aerated as aerobic treatment. Now there's something called anaerobic treatment, similar process, only they don't add aeration to it. And basically it's bacteria that doesn't need a lot of oxygen is doing the same kind of thing. And then the third method, or the third part of treatment of sewage, is disinfection. Some of the more advanced, I guess say expensive systems could have UV lamps as a part of their disinfection. I don't really see that with small systems, or definitely not with houses or businesses, not very often, if ever really. Mostly what you'll see is a chlorinator. And what they use is these chlorine tabs like you'll see on the left. And I'll talk about that in a little bit detail further. So we have primary treatment, which is the physical removal. Secondary treatment is using the biological processes to break down the waste and the solids. And then you have disinfection. Those are the three main types of treatment. Now we're going to go over the types of on-site sewage treatment systems, and you'll see where these different types of treatment comes into play. The first type I'm going to talk about and how they operate are conventional septic systems. Now these are basically comprised of a septic tank, and the flow goes into that, then it goes out the other side into a subsurface absorption field. These actually are the types of on-site sewage treatment systems that are preferred in the regulations in the state sanitary code. But the caveat is the property on which these types of systems are going to be put, they have to pass what we call a percolation test. For that drain field has to be able to drain the water, the wastewater, into the native soil, and that native soil has to be able to absorb it, drain it further down. If it can't do that, you can't put in a conventional septic system with a drain field. So that's why you see a lot of these mechanical treatment systems in certain areas. So conventional septic systems, generally what you'll have is a big tank. Sometimes it can have multiple chambers. If you look to the left, it says inlet from the house. Basically, that's the sewage coming in, and it flows into the tank where it slows down, it settles, all the solids by gravity settle down to the bottom, and they form a layer of sludge, and that's where some anaerobic bacteriological action starts happening to break down the waste even further. And then the floating stuff like grease will form a scum layer at the top, and then everything in the middle is supposedly supposed to be somewhat clear, and it generally is fairly clear. That clear stuff, and you can see the way the pipe to the right, the way it's situated, so that only the liquid portion will be able to go out to the absorption field. So that's the basic method of treating sewage in a conventional septic system as far as the tank goes. So it's mostly primary, but also a little bit of secondary with the anaerobic action. So on the left, again, you see the tank, the conventional, the septic tank. This one actually has two compartments. So that second compartment clarifies the water even further. And then the water goes out through that perforated pipe for effluent disposal. Basically, the water seeps out into that gravel bed, and then from the gravel bed, it goes down into the surrounding soil. And the idea is it will actually break down even further anaerobically in that soil, in that gravel bed, and it should never discharge. These things are not supposed to discharge. If they do, something's going wrong. And again, these are actually the type of systems as far as on-site sewage treatment systems that are preferred by the sanitary code. But where you can't put one of these in, which is quite frankly a lot of parts of Louisiana, we have to put in what we call a mechanical treatment system. You also will hear it referred to as an aerobic treatment unit or an ATU. And again, it's aerobic because we're providing through mechanical means. We're doing both the primary and secondary treatment by using aerobic bacterial action. And we do this by blowing air into it or stirring that water up, basically getting oxygen to the bacteria So that aerobic bacteria does what it does and breaks down the solids. The top left corner, that green tank, is what one of these ATUs looks like before they're installed. The bottom left corner is generally what I see when I'm out in the field looking for them. Basically, you'll have those circles are covers over a tank or a chamber within the tank. It could be more than one cover for one tank because they might have multiple chambers. And that's a port where you can actually get into it and check on the system itself. And then you'll see that electrical hookup, and that goes to this covered thing. And that cover basically is over a motor with an air blower to it, which provides the air to the tank itself. And then at some point, like you see on the bottom right side, there'll be a discharge pipe for the effluent that comes out of these mechanical treatment systems. And pretty much they discharge often, if not all the time, when they're working properly. This is just a schematic of actually how one of these mechanical treatment systems works. You'll see the raw sewage comes in from the left, and when it gets into that first chamber, and they don't all have this first chamber, but this is one that does, the solids break down, the sludge and the heavy solids goes down to the bottom through gravity, and the floating stuff stays at the top. That baffle keeps most of it from getting into the aeration chamber. There are actually two baffles with this one. The water flows, the more clear water flows into the aeration chamber. This schematic looks like it actually might be one that has like a little propeller at the bottom. And mostly what I see, just from my experience, are ones that have air blowing into it. But it's basically the same thing. You're providing some kind of means of producing or adding oxygen into that water. And what that does, again, is get the aerobic bacteria excited and hungry, and they break down the solids. So they do what they do, and eventually some of that water starts flowing up to the right side into that clarifier. And the lighter water, the more clear water, actually discharge through the discharge pipe, while the solids will actually start, after the water slows down, start going back down that angled area and get sucked back into that aerated portion for reactivation, basically, to be broken down further. Now, if you have any kind of disinfection, like chlorine tablets or whatnot, they would be involved after that part of that pipe to the right. So that's basically, in basic terms, what mechanical systems do and how they treat sewage. And again, you can see it's both primary through the sludge settling down, and then secondary through the aeration. This is just an example of another schematic of a type of mechanical treatment system. Now try to think of this one in a 3D format. This one I think would be more like a cylinder. So the sewage from the house or wherever comes in on that left side, and all around the outside of it are these aerators blowing air into this aeration chamber, which surrounds the whole cone. And that breaks down the solids aerobically. And eventually some of that water starts filling into that cone in the center. And as it slows down, the solids, again, if there are any solids left over, returns back into the outside so that it's recirculated again to be broken down further. Meanwhile, the more clear water goes up into the center and flows out by gravity to the effluent pipe. Now, these are the different parts of a mechanical treatment system. Pretreatment. These are optional, not all systems have it, but basically it would be like a septic tank or some kind of primary settling tank, kind of like we saw in that first schematic, or a screen like a trash trap, and that's to get the big solids out. Then there'd be an aeration chamber. That's where the oxygen mixes with the wastewater. And again, what we're doing is we want the beneficial bacteria that eats the other bacteria to thrive. We need them to be alive and doing what they do so they can break down the sewage. Then we'll have some sort of clarification. That's that clarifier chamber. The solids, after the water slows back down, the solids settle back down and returns back to the aeration chamber. If there's any scum left over, it'll rise and will not be able to go out through the pipe. hopefully there won't be any scum on that side of it. And then the clear water leaves the system as effluent. And then if you have disinfection, and I say if because these are optional for homes, the way I understand it in the sanitary code, disinfection is encouraged for houses, but it's not a requirement. But if you have like a DEQ permit for a business that has your own sewage treatment system, and I think also the same with the Department of Health, I'm pretty sure it is a requirement. And I know for DEQ, because I work for DEQ, you will have effluent limitations that do require some sort of disinfection, because you have to get some of your coliforms levels down. So it is a requirement to meet your effluent limitations at the very least for DEQ. What they do is they use calcium hypochlorite. It's actually labeled specifically for wastewater disinfection. This is the most common thing we see in Louisiana. It can't be like a chlorine tablet for like a swimming pool. It's got to be some chlorine tablets or a specific type of chlorine tablet that is specifically for wastewater treatment. And the Department of Health says you have to maintain minimum residual chlorine of 0.5 parts per million. So that is actually in the code. Effluent reduction. Not all places have to have this. There are certain systems that do, and I'll talk about that in a little bit further. But basically, these are ways of making the amount of water coming out of your system have less effluent discharged out into the environment. So let's look back at the aeration chamber. This is again part of an aerated treatment unit or mechanical treatment system. This picture is a good example of what you want it to look like. A long time ago, when I first started at DEQ, I was writing permits for sewage treatment systems. And I was at a system, pretty large one, or kind of, as far as they go, medium size actually, but I think it's treated sewage for like a hotel and maybe a couple of restaurants. And so the sewage treatment handler, the operator of the system, was taking us on a tour to kind of show us what to look for. And we had like a large grate over the aeration chamber that we can actually walk over it and look down into it. And it didn't stink. It smelled kind of earthy, and it had like an earthy color to it. And what he told me was that's what you're looking for. If it's kind of a brownish earthy tone and it has like an earthy smell to it, that means your aeration chamber is doing what it's supposed to be doing. So keep this picture in mind if you haven't seen something like this before, because this is what you're looking for. So with these aeration chambers, you're either going to have an aerator, which blows the air to the system, or you're going to have an agitator, which basically operates some kind of motor that operates paddles or stirs. But the whole idea is to add oxygen to these systems. And this heart of the system just beeped. I didn't know it would do that, but the aerators are actually the heart of the system. Without the aerator working or the agitator, your system is not going to be working properly. Some of the systems, quite a few of them actually have controls and alarms, and basically they tell you when something's going wrong, and you should be able to see them and hear them. They'll have a little red light, sometimes they'll have a buzzer, those kind of things, and they'll have like a button to turn them off. But if you hear that buzzer or that light is lit, don't turn it off and just walk away. That means something is going wrong. You can have a system that's being clogged up. Some of these systems have like a floating switch, kind of like the back of a toilet. When you flush your toilet, you know, the back of it starts filling up and there's a float as it goes up to a point, it switches the water coming into the toilet off. Some of these systems actually have those in the actual tank itself. And that way it knows when there's too much water going into it, which means there could be a clog on the other end. And so your system is backing up, and that would keep the system from backing up into your house or to your business. So at that point, you would need to figure out how to get the thing unclogged, snake it or whatnot, do some troubleshooting. So these things are here for a reason. Don't just ignore them. Some systems actually have lift stations on the other end of the treatment side to get the sewage or the treated effluent to a sprinkler system. For the most part in Louisiana, I think they're used for sprinkler systems, but they could be used to go to a mounding septic, a drain field, or just to get it further down into a ditch. They're not very common from what I've experienced, but they're out there. But these things will have alarms as well. So the main thing out of this, do not ignore any alarms. They're telling you something. And this on the left is what the alarm looks like. On the right is an example of an alarm that's attached to the actual motor with the blower. And we'll talk about those in a little bit, but these things actually have to be maintained. These motors and the blowers, the aerators basically. So that's what an aerator looks like. That says Troy Air on the right. Again, lift stations, I don't think they're that common. Some Department of Health people may say otherwise, but I haven't seen them very often as far as on-site sewage treatment systems. But I know they do. Sprinkler systems are becoming more common. They're using in more places, and these are used for those. And sprinkler systems are part of an effluent reduction program that the Department of Health started back in October 20th of 2000. Basically, it required individual sewage treatment systems with a capacity up to and including 1,500 gallons per day that produce treated effluent and which, by design, do not significantly reduce the amount of off-site effluent. So again, if there's any further questions on this, we will have to refer you to the Department of Health, but I did want to put it in there just to let you know that it's out there. And I haven't personally been around too many of these things, but I did see some in a neighborhood that looked just like this one pictured. We were doing some work to clean up the sewage getting into Sibley Lake, which is the drinking water supply for the city of Natchitoches. And one of the neighborhoods around Sibley Lake looks just like this. And I think all the homes had these on-site systems with a sprinkler head on it. And my experience just from being down there for a week or so, I never did smell any sewage. It looked like they were doing what they were supposed to be doing. But I think there has to be a certain component of the soil has to be able to simulate it maybe. But what I saw wasn't an issue. I have heard stories of people having like Super Bowl parties or outside weddings, and the sprinkler system for the sewage comes on and it just smells really bad. If that happens, you know something is going wrong with your sewage. It shouldn't be smelling that bad. And then some other types of on-site sewage treatment systems. There are septic tank systems. Basically, they're somewhat of a combination of a conventional system with some aeration. Sometimes they have a field line, a field absorption line. I think actually my boss at DEQ may actually have an aerator with a field line and actually has a pipe on the end of that. Basically, it's a method of reducing the effluent. So that's what I mean by septic tank system. But basically, it does the same thing as either an ATU or a conventional system. And then there are oxidation ponds. Now, I really don't see oxidation ponds anymore for individual homes, sometimes for businesses. Mostly they're for more than one house, or more like a larger city or a small town will have one. For example, I live in St. Francisville. Like I said earlier, we use an oxidation pond, but I don't know anybody around the St. Francisville area who is not connected to a city sewer that has an oxidation pond for their house. It's just not that common. Okay, now we're going to get into maintenance. And again, this is some general stuff that I know from teaching the class. And I'm going to get into a little more detail than I normally do. And for that, I'm pulling from a lot of the classes that I've done in conjunction with the Department of Health. So this is a slide I put together a long time ago for septic tanks. The sanitary code says inspect them every 6 years and pump the sludge out periodically. Mechanical systems, you have to inspect the electrical components, mechanical components, check your effluent, and if you have a smell, and then pump the sludge out periodically as well. Now, the thing about pumping out sludge for both septic tanks and mechanical systems, I think further on there's a slide that says the Department of Health recommends or has some guidelines for how often this should happen. But truthfully, it's really according to how much input is going into the system. So think about like an example like this. An elderly lady living by herself, she has her own sewage treatment system, whichever type it is. She will not need to treat or need to pump out or have her system pumped out as often as, say, like an active middle-aged couple with like 5 boys that all play football. You can imagine that system will be loading a whole lot more through multiple people, more washing going on, a lot more eating going on. It's just the way it is. So it really kind of depends on what's going on in your house as to how often you have, or your business, as to how often you have to pump your sludge out. And in a little while, I'm going to tell you a good way of finding that out, how often you should do it. For oxidation ponds, and again, we don't see these very often for on-site systems, but if you do have one, the main thing is to keep it sunny. Keep any growth, vegetative growth away from it. If you're cutting grass along the thing, don't shoot your yard clippings or your grass clippings into the oxidation pond, because eventually that stuff will start breaking down, which will mess up your dissolved oxygen and get it all off balance, things like that. You want to keep them sunny because the sun actually helps with the process of breaking it down. And I want to say, unless you have some kind of aerator in it, it's an anaerobic bacterial reduction is what's going on in there. Also, if any replacement parts anything needs to be replaced on any of your systems, you have to be sure that you use parts that are approved by ANSI, by the manufacturer for that specific type of system, and through the Louisiana Department of Health. You can't just basically go to a fish store and get like a fish tank's aerated unit to stick it on your aerated treatment unit, basically. So let's go deeper into mechanical systems. These are, again, the aerated treatment units, some more about their maintenance. And this first one kind of goes for all of them, but it's really for these mechanical systems. Learn what normal is. If your system has just first got put in, or it's just been maintained or cleaned out or whatever, go look at it. See what it smells like, what it looks like. Touch the blower, the blower pump. See how it feels. Maybe touch the cover on the outside of it. See what that feels like, because any change of any of that could indicate something's going wrong. So know what your system looks like, what it's supposed to do, how it's supposed to smell. Look at the effluent, see what it looks like, when it looks good, and then check it periodically. Because if it changes, if it starts turning brown, if it starts stinking, something needs to go on with your system. Periodically look in that chamber to make sure that there's agitation, that the water is being disturbed. And again, you want to see the color of the water. Again, what I was told and what I've seen is an earthy tone with an earthy smell. Make sure you don't have scum being built up, like a lot of grease just being trapped on the top of the aeration chamber. That shouldn't be going on. There's always a line from these blowers to the actual aeration tank itself. Check these lines. Sometimes they can get dry rotted. Sometimes people accidentally cut them with, when they're out mowing or weed eating. Sometimes they get knocked loose or they just fall apart. So they have to be sure that they have a seal between the blower and the system itself, no holes in it. Otherwise, that system is not doing what it's designed to do. It needs that specific air coming from that specific blower through that line the way it's designed for it to do what it's supposed to do properly. And here's where it is. The Department of Health, their guidelines says to have the system pumped out at least every 4 years. But again, that's a guideline. You may need to do it more than that, depending on your loading into your system. And I kind of covered some of this a little bit, but just to reiterate it, because it is very important, maintaining the blower is essential to the treatment process, because that level of aeration is what it's designed for. Your system is designed for your specific home or business. When they put it in, it's engineered to do what it's doing for what you have going on, basically. and any variation in that could potentially upset your system. So keep the blower and the motor running. Check and clean that filter as necessary. Remember, we were showing a picture of one of these housings where the motor is located, and there's usually a diaphragm in that motor, and it's sucking air in through a filter. Check that filter every so often to make sure like grass clippings haven't gotten into it or too much dust. In here, I say keep ants away from the unit. You don't want, for whatever reason, ants keep going into these things. I see that quite often. I think it's something to do with the heat, or they can get underneath that housing and it's warm and it vibrates, so it makes them feel comfortable. But ants can tear your motor up. And again, when you're cutting grass, don't have your grass cuttings going toward that blower. I've seen people actually use some pretty landscaping around these units, specifically around the blower itself. Not right up on it, because you want some airflow getting into that thing. You want to obstruct it. You don't want any kind of vegetative cover covering that thing. Keep it separate, but you can make like a barrier around it to keep grass cuttings from getting into it. Okay, now we're talking about effluent handling. This is the discharge coming out of the system. And this actually applies to all systems that have lines, which are pretty much most of them, going out. An effluent line that goes to a ditch or a drain field, you know, with that absorbing quality for that gravel and going into the soil. These lines, you cannot drive equipment over them. Don't park your vehicles on them. Don't landscape over them, because the roots can get into the lines, especially tree roots, and can clog the lines up. And when the lines clog up, that creates backups into your system. And if you're gravity fed and you don't have an alarm, you may not notice that your system is filling up until it starts banging up into your house or into your business. And that's what we don't want to happen. Also, similar things can happen if you allow surface waters to accumulate over these lines, because it can back up into the system itself. And basically, you're overloading the system reversely and causing it not to treat the sewage properly. And again, some systems, and again, I haven't seen these often, but some systems have lift stations and they should have alarms on them. So check the alarms every so often to make sure they're working properly. That way you know the lift station, which is basically a pump, is working properly. And you have to, if you have to replace any parts, be sure you use approved parts. Again, these lift stations, sometimes they'll be used for sprinklers. These sprinkler systems, like we showed that picture earlier, look like a nice subdivision with like pine trees and whatnot. When they're put in, check out the spray. See what it looks like. Get used to the spray pattern, because if there's any deviation in that, it could indicate something's going wrong. Sometimes the sprinkler heads will need to be cleaned. What I understand is they can build up with some biofilm. If they have pre-filters to kind of clean the gunk out before they go to the sprinkler itself, you have to clean those periodically. And again, any kind of parts that need to be replaced, use only approved parts that are specific to your system. And if you use disinfection, now, if you're doing this for your house, if you're listening to this for your house, most likely you don't have disinfection. If you have a business with like a DEQ permit, you probably do have disinfection, or you should. Be sure you monitor your disinfection for effective tablet use, and only use the tablets. And this one says calcium hypochlorite tablets, but be sure they're used or specified to be used for wastewater disinfection. And I've been to, when I did permits, I've been to like inspections before, where you go look in the chlorinator unit, basically the chlorine chamber, and there are no tablets in it. That kind of stuff happens. You have to be sure you have enough tablets. Be sure and check it. And one way of checking that you have enough tablets is to keep records of everything. If you have a DEQ permit, so I'm going to get into some permitting for just a second. If you have a DEQ permit, say this is not for your house, but for your business or whatever, and you have a sewage treatment system that makes you, you have a discharge, which means you then have to have a permit from DEQ. That permit will specify what you have to keep a record of and how often. Now, for everybody though, in general terms, these are the kind of records you want to keep. The model of the system that you're using to treat your sewage, its capacity, the data that it was installed. And then if you get when you get a contract service agreement, keep that contract, including any pump out receipts. Whenever somebody comes to pump out your system, get a receipt and hold on to that. And then make a record of all those pump outs or any other kind of service visit. Or if you did any maintenance yourself, like adding chlorine tablets or fixing a blower or cleaning that filter out, the longer you maintain records, the more often you'll be able to see for in the future, most likely when something will need to be done again. I wish I was in front of a group of people because I would like to see everybody's heads nodding yes, but if you're by yourself, nod yes right now so that you know that you say what I'm saying, understand what I'm saying. Keep your records and it will help you for the future to know what needs to be done. And that's very simple stuff. Okay. See it locked up. All right. Now these systems are made specifically for a certain amount of water for the certain property that is designed to treat when it was approved by the Louisiana Department of Health. As such, they cannot be overloaded. If you hydraulically or put too much water in it, hydraulically overload these systems, they're not going to work properly. You're not going to be treating the sewage because they need time for the bacteria to work on them. And so basically you're just going to have, in essence, if you understand what the term bypass means, you'll be having your own little bypass going on and discharging untreated effluent, untreated sewage into the environment around your house. Or if you have a field line, there's more of an opportunity for the solids from that sewage to get into that field line and clog that field line up. So what we say is conserve water. You'll see what we're doing now is the do's and the don'ts of sewage maintenance. So conserve water, and this is for everybody. Leaky faucets or runny toilets, repair those. That's overloading your system. It's basically a constant drip of water going into it. Try to use water saving features on your appliances. And when it comes to washing your clothes and your dishwashing, try to spread those out. Don't do it all in one day at the same time because that's going to overload your system. Some other examples, say if you have like, again, we've heard of like people having a Super Bowl party and a ton of people there and they're all using the one or two toilets and something goes wrong. Sometimes that's basically it's just too many people using the system and it's hydraulically overloaded. The system can't keep up, and sometimes you can end up getting a smell because of that. So those are things just to be thinking about. Now this one is not talking about hydraulically overloading the inside, the interior of the system, but now we're talking about the outside of it. You want to keep water away from both the system itself, the tanks and the chambers, and the drain field, and the water, the effluent pipe going into whatever ditch. Make sure it never gets, well, try to make sure it never gets inundated. I know in Louisiana it's pretty hard because we got a lot of inundation all the time, but water getting into these field lines or standing water over your tank, it can infiltrate that system. Some of these tanks could actually, if you get enough water, they can actually pop out of the ground. I've seen that with some of the hurricanes that we've had. But in basic terms, don't drain your roof, that water to your system. House footings, keep that away. Don't have any stormwater flow going in it. If any sump pumps that you may use, don't direct that flow to where your system is located. And again, I know this, we've said this one before, but become familiar. Know what your system looks like, what it smells like, what it feels like. Just be familiar with it. It's similar to don't drive or park over the drain lines, don't park or drive over any part of your system, whether it's the line or the tank itself. A rupture to a line or a rupture to the tank is going to cause a breakdown of the system, and you're going to incur repair costs. Speaking of repair costs, do not make or allow unauthorized repairs or changes to your system without obtaining a Department of Health permit. So basically, the Department of Health regulates the placement or the, I guess, the approval of the type of system to use for your property. And any changes to that has to be run through them because that thing is designed for what you're doing. Also, it says don't open or attempt to clean or perform maintenance on any sealed components. Okay, further into maintenance, and this is, again, all systems, whether you can perform routine maintenance on your system yourself or not. This last one, don't park or drive, and especially this one, everybody can do this. Your system is only as good as what goes into it. So don't flush or pour harsh chemicals into your system. Basically, these things, again, they use this bacterial action to break the waste down. It's anaerobic in a conventional septic tank system, and it's aerobic in one with an aerator. But you need the bacteria doing its job to break the bad stuff down so that it doesn't contaminate the environment, make people sick, or clog your system up. And if you pour too many chemicals down it, you could be killing this bacteria, which at that point, you could be ruining the way your system's operating, again, clogging that system up and creating more opportunities for backup. And I've heard when this happens, you may have to actually pump your system out because some of that sludge just may not be worth anything anymore. I've also heard that a lot of times you can basically just keep your system back up and running again. You may have some issues for a while, but they can correct themselves after a period of time of regular use. Sorry. Anyway, bottom line, don't flush stuff that doesn't go down it. And don't use a garbage disposal. This thing says if your system wasn't designed to accommodate this type of waste, I don't really know many of them that are. So what I just tell everybody, don't use a garbage disposal. Don't get one in the first place if you have an on-site system, because these things are not meant to break down waste, food type waste. They're meant only for toilet paper and human waste. Sewage, basically. And as far as your system, some people ask, can I put some additives into it to make it work better, or if it goes bad, that kind of stuff. The Department of Health does not recommend adding any additives to your system. And basically they said, and I've read this from all sources, basically, there's nothing really documenting that it improves the solid digestion or any kind of line clearing. It doesn't really do anything. So you're basically wasting your money from what I understand. As long as you're using that system properly, not adding in anything into it that doesn't go into it, like pouring chemicals down it, it should be working properly, and you should not need to add anything to it. Maintenance, further maintenance, and again, these are for all types of systems, for everybody. And usually at this point, we get a good chuckle from the crowd, so everybody laugh amongst yourselves, I guess. Yeah, don't flush cats down it. But basically, don't flush anything besides human waste or toilet paper, especially these flushable wipes. They're really not flushable. Yeah, they'll flush, but once they get down there, they wreak havoc on all kinds of systems, including city systems. If it doesn't belong in it, don't flush it down there because it can ruin your system and clog it up, which will cause backups. Tamika, I thought we took all these things out, but it looks like they stayed in. Maybe I picked up the wrong one. Anyway, more maintenance. Again, don't flush chemicals. So these are just some examples. Paints, varnishes, thinners. waste oil or fats or grease, like cooking grease. Sometimes I've actually done this where like I'm cooking something, I get a lot of grease, I'm just too lazy to go outside, and I run some hot water and I pour it down the sink. I've done that a few times. When I do it, I'm like, no, I know better than this. Like, none of us should do that on any system, because that grease, once it gets into your line, it's going to cool down and it will congeal. And once it congeals, you know, more grease will build up behind it, more stuff builds up behind it, and that will clog the line going into your system. And then you won't be able to flush your toilets and that kind of stuff. So do not pour grease down your sinks. Don't add it to your system. It can get your system off kilter, and the bacteria won't be able to do what it's doing because it's not meant for grease. So this is a bad thing. I just told on myself a little bit too, but I try not to do it myself. As far as placement and some general regulations, now this slide is from a presentation I did to a bunch of water operators. And so I was kind of taking it from a public water system standpoint, which is why I included these things. So, but it's interesting for everybody to know. When it comes to water wells, there are setbacks for septic tanks, mechanical plants, and oxidation ponds, and as far as water wells, and also for reservoirs, and for just basically any component of a sewage system. Basically, we want our sewage system to be away from our source of drinking water. You have to get installation permits from the Department of Health. Again, I said this earlier, but conventional septic tank systems are preferred if you can pass a percolation test. And then for mechanical plants, their specifications have to be approved. There's an engineering group at the Louisiana Department of Health that approves all these mechanical systems. A minimum 2-year service policy must be provided. And then after that, the owner is responsible for perpetual maintenance. They have to be kept in service and in a serviceable condition. And discharge from septic tanks are prohibited. Remember I said that earlier. These fill lines should not discharge. It's actually prohibited in the sanitary code. If you have a discharge and you're not a house or a residence or a camp, you have to have a permit from DEQ. We regulate any discharge of wastewater from anything other than a individual home or basically a camp. So churches, any kind of business that has their own system, you know, restaurants, you name it, we actually regulate those. Then also the Department of Health regulates their construction, their installment. That's where their permits come into play. And then their continual maintenance. That's where the regulations differ. So we look at the environmental side at the discharge. They look at the installation and the maintenance. The Department of Health does. Again, this is more regulations, and from just reiterating some of this stuff and adding to it. The Department of Health says with purchase of any aerobic treatment unit, the first 2 years of service are included. It's not necessarily covered by warranty, but you have to have that 2-year service plan. Then after those 2 years, either contract with a licensed installer for your brand of system. It has to be somebody that can work on your system, or become certified through the on-site wastewater program with the Louisiana Department of Health to provide maintenance on the system at your primary residence. So what's that saying is you will either have to get any kind of repairs done or get your system pumped out. We'll have to get somebody who's certified to do that, or you must become certified to do it, to make any repairs or any kind of maintenance like that. However, when it comes to the maintenance, the general maintenance, like looking at your filters, becoming familiar with your system, watching what goes into your system, not pouring stuff, checking your effluent, looking to see if your excuse me, if your blower is still working, all that kind of stuff. Everybody has to do that. We all have to do that if we have one of these on-site systems. But if you get certified to work on your own system, what they say is it no way replaces the need to seek professional assistance from licensed individuals such as on-site installers, electricians, or plumbers. And then when issues are beyond routine maintenance, still seek the services of a trained professional. And then the Department of Health also says that proper electrical connections must be made to the air pump, blower, and or any other electrical components that are integral parts of an individual mechanical sewage treatment plant. And basically, a qualified electrician should perform or examine the installations for appropriate wiring and installation, as well as connection to the GFCI, those outside outlets with the breakers installed on them. And this is where the bottom where that is specified in the code. So basically, if you get above your head and if anything electrical is going on, you have to have somebody that's certified to do it. Okay, now most of this so far has been more from the Louisiana Department of Health, a little bit about DEQ's permitting. Now I'm going to get into the portion of the talk that I usually do when we do our sewer classes. Checking my time. And we probably got about 10 or 15 more minutes. So why do we care about all this stuff with sewage? Well, basically, DEQ, just to kind of tell you a little bit about what we do. We control the introduction of pollutants into the waters of the state through permitting and through best management practices, those kind of things. And when we talk about waters of the state, we're talking about both surface water and groundwater. So it's rivers and bayous, aquifers, the water table, little dry sandy creek beds, even ditches. All these are waters of the state. And the basic premise is you cannot spill or discharge anything into the waters of the state without a permit from DEQ, unless you're a house, it's from your home system. For all these systems, excuse me, for all these water bodies, all the waters of the state, we've actually divided them up into smaller units of drainage. And all these drainage basins go to one single named water body. And for each water body, we have different surface water use designations. So there are these various designations, which basically means we want this water to be certain things, to do certain things for us. There is primary contact recreation. This is all water bodies. Basically means we want to be able to swim in all water bodies. There is secondary contact recreation, which is the boating or fishing standards. This is all water bodies. We have to be able to boat and fish in all water bodies. We have fish and wildlife propagation. This is most water bodies. For most water bodies, you have to be able to support fish and wildlife. There is drinking water supply. Some water bodies are supplies for public water systems, like Bayou Lafourche, Toledo Bend, Caddo Lake, Cross Lake. Some water bodies have oyster propagation going on in them. Some are used for agriculture. Some are outstanding natural resource waters. Think about the prettiest waterway you've ever been to, canoed, kayaked, or fished down. That's what we're talking about with outstanding natural resource waters. So for all these waterways, they have these designated uses. And what we do is we apply surface water quality standards to them. And the idea behind these standards is so that we can make sure that they're meeting their designated uses. So we have different standards for different pollutants. The idea behind them is they provide protection for the ecosystems, for human health. Actually, think about this too. If you have a standard to a water system, water body, we can measure against that standard and see whether or not it's meeting its water quality standards. And if it isn't, we can actually figure out what to do about it to fix it. So in a way, by having standards, we can enhance the quality of the water. And basically, we have to do these to meet the requirements of the Clean Water Act. So we have standards for fecal coliform. Basically, we sample all the waterways for different pollutants, and fecal coliform is one of them, just to see if the standards are met for them. Just to kind of explain what fecal coliform is, basically it's a bacteria that's found in the intestines of warm-blooded animals, and it's excreted in their feces. It can come from humans, pet waste, agriculture, livestock, anything like that. Basically any kind of warm-blooded animal can excrete fecal coliform. Now, the thing is, fecal coliform, we use it as an indicator organism to know whether or not something may be in that system or may be in that water that's harmful to us. So we can't identify whether or not it's sewage, but we do know that it's there. Something is there. So we use it as an indicator organism. Excuse me. Now what we see doing our sampling at DEQ, that fecal coliform is the second most common listed suspected cause of impairment out of 499 total watersheds, 148 of them. Basically, knowing what I know at DEQ, we do have an issue with fecal coliform impairment. This next bullet where it says suspected sources of impairment in number of watersheds, basically this talks about the different types of causes of fecal coliform impairments. This is for on-site sewage treatment systems. There are 93 watersheds that are having issues with on-site sewage treatment systems. Package plants and other permitted small flows discharges, there are 51 of those watersheds. Then sewage discharges in unsewered areas. These are areas that don't have community sewer systems. 38 watersheds are having issues with that. And then you can see municipal point source discharges and sanitary sewer overflows. So we know we have this fecal coliform and all these different watersheds are impaired from it. But what does that mean? Why do we care? What do the numbers mean? Well, it can indicate the presence of sewage in water. And why do we care about sewage? Well, it can make us sick. It could cause a wide variety of illnesses, including diarrhea and infections. And what it is, it's the pathogens in the sewage. It's the bacteria, the parasites, and the viruses that can make you sick. Also, do y'all remember last year or year before, there were some reports coming out of, I think it was out of Florida, of blue-green algae outbreaks. Sewage, the nutrients in sewage can cause algal blooms. And this blue-green algae is actually toxic to humans. It can make us sick. So that's more than likely what was going on there. And then pharmaceuticals can be discharged in sewage. Usually I'm in front of a crowd of people and when I ask this question, but think about it to yourself. If you've taken some sort of medicine within the last month or so, just think to your head yes or no whether or not you have. Most of us have. Generally when I ask that question, everybody raises their hand. And you know, that's fine. This is the way things are nowadays, especially as we get older. We need more pharmaceuticals, it seems like. But the thing is, be sure you take all of them appropriately according to the labels, use them up like you're supposed to. If you overtake medicine, you most likely are passing some of that stuff through into your toilet. Or if you have leftover medicine, don't just dump it down the toilet. Zip it up in a Ziploc bag and dispose of it in the trash can. Because these sewage treatment systems, even a community system, none of them are made to treat out pharmaceuticals. And we're just now learning the different types of things that pharmaceuticals are doing out in the environment. Think about everything we take medicine for. That's the possibility of what it can do when it gets out into the environment. The thing about the exposure to sewage and the sickness is mostly short-term, no lasting effects, but it can be unpleasant. It can be violent. Some people that, like especially children and those with weak immune systems and older people, can die from exposure or have long-term illnesses. My example I'll give here is cryptosporidium. I think there was an outbreak in Milwaukee a few years back and some people actually passed away. At this point, I always like to add a little personal anecdote. About 10 years ago, maybe, well, actually 15 or 20 years ago, it's been a while now, we were water tubing in one of the local rivers, and as we got into it, you know, floating, having fun, about halfway down, we started smelling a sewage smell. And then a couple times I actually did see a discharge pipe with water coming out of it. And it didn't look bad, but it had a smell to it. So I was pretty sure that we were water tubing in sewage at some points. And I want to say there were 10 of us on the trip. 9 of us that night all got sick, including myself. And what I felt was like a malaise, like a low-grade fever, and like just really bad stomach upset. Lasted for about a day. After that, I was fine. So you can get sick from it. It's happened to me. A lot of times when I give this portion of the talk, I'm talking to public water system operators. So I always like to include this anyway, because it is good knowledge, especially if you're located in an area where there's a public water system that uses a surface water supply. For example, Bayou Lafourche. The water is treated by the public water system. The Department of Health is doing a really good job of checking on them. They're doing a good job of making sure that the water is clean, so when it comes out your faucet, it's safe to drink. I do work all over Louisiana, and everywhere I go, I drink out the water fountains or out the taps. I never bring bottled water with me. There's no point to that. The water's fine. At least it's safe. But if there's a lot of sewage in this water body, like Bayou Lafourche, it will cause the water system to do more treatment. And generally what they do, they use some sort of, for disinfection, use chloramines. And that chloramines will actually bond with the organic materials naturally in the water, but also there's more of it in the water because of the sewage. And when it bonds, it creates a chlorine byproduct, which we now know over long-term exposure of ingesting chlorine byproducts, we can get cancer. So now the water systems are having to treat out the chlorine byproducts as well. So they're treating the water and then treating the treatment. And all this increases the cost of treatment. And when it comes to cost, we all end up paying for it in the long run. So let's talk about some of the environmental effects of sewage. You'll get low dissolved oxygen because there's so many nutrients and so much organic material going into it. You can have some issues with the dissolved oxygen, and that's where you get fish kills. Algal blooms are an issue. We talked about that earlier. Again, that's from the nutrient loading. Sewage can release toxic materials as well, which can be really bad for the environment. It increases turbidity. Basically, you'll have a lot of sedimentation, a lot of dirt looking in the waterways, which degrades all the soil and vegetative cover. It could change the water temperature. It all kind of goes hand in hand. Basically, it could kill the waterway. So how is sewage getting to the waterway? Not just discharging out untreated sewage, but there are other ways. Poor placement of the septic leach field, badly constructed percolation systems, system failure, like they're just not working from not being maintained properly. Something that we see may be an issue in a few places is just, frankly, there's too much of them. There's a high density. And then there could be site-specific stuff like soil properties. The water table could be too high, the geology is not right, and there's too much vegetation. So at this one, I'll put at the top the title of this particular slide, Louisiana Department of Health Permitted On-Site Sewage Systems. The only reason I did that is to show you that this is where this data comes from. All these dots are a permitted system that somebody has installed and got a permit from the Department of Health. And I'm not blaming the Department of Health for letting all these things occur. They have to do this because that's the way we're going to make sure that these systems are being maintained properly. This has to happen. But sometimes, quite frankly, there's just too many of them. And just look at how many systems are there. Eventually, some of them are going to break down, and there's kind of an accumulative effect of just too much sewage getting into the waterways. Okay, let's look at some different failures and how you would notice those. Some noticeable signs of when your system is failing. There could be backups, slow drains, backups into the toilet. I have to mess with Tamika, the organizer of this thing right now. Usually when I do this talk, I never put really gross looking pictures in it. but I thought, let's put a picture of a backed up toilet. So I found the least gross looking one I could, put it in there, and the rest of them I just couldn't take a look at them myself. Tamika couldn't even look at that one. So imagine how gross the rest of them are. So just don't look at or don't Google search toilet backups ever, because it's not fun looking. It's really not fun looking if it happens to you specifically in your house or in your business. You maintain these things, and that's not going to happen to you. You don't never ever want to see that. You can also see it in the ditches. This picture to the right, you see it's kind of gray. It's got some stuff hanging out the pipe. Whenever I see that, I know there's sewage is not being treated very well. And then you can smell it. When it's out there not being treated properly, you can smell, you can tell there's a sewage odor. Another sign is you'll see some pooling of water either over the tank itself, like you see on the right, or over the field drain, the drain field, like you see on the left, and you'll be able to smell that as well. That means something's clogged up or backed up, or there's too much loading into it, which all kind of goes hand in hand. Whenever I go into a neighborhood, especially like September, October, it seems like it rains all the time now, but if it hasn't rained like a month or so, it's really dry, yet you still see lush green grass like this, or algal blooms like on the bottom right, or this lush growth, not the grass, but the actual growth in the ditch. I'm pretty sure that's sewage. That's kind of stuff that you're looking for. You can also find out if there's a failure through the monitoring data. You'll have an increase in total fecal coliform. Your dissolved oxygen will get all messed up. Total phosphorus, nitrate, nitrites, turbidity, all these are things we can sample for to check for it. Again, you'll see a lot of algae because of the nutrient loading. And then when that dissolved oxygen goes down, or if there's anything toxic, you'll start seeing fish kills. So these are all ways of seeing if there's failures. And why is it important that we keep the sewage out of water bodies? I'm almost done. First of all, it mitigates the degraded environmental conditions that affect not just us, but also the environment, the fish and the wildlife. Also, if we get this stuff out of the waterways, especially for these places that use certain waterways, certain water bodies for public water system, for potable water, maybe they would be able to decrease their treatment and have a reduction in cost. It'd be a lot easier to keep your water clean than to clean it up. Also, waterways do close down. You can't swim in some of them sometimes because there's too much sewage loading going into it. That does happen, just like you see on that little picture on the right. I've seen those signs before. It does happen. And then anytime you have a lot of sewage in an area, there's always a financial burden. Somebody has to clean it up. And also think about this. Have you ever gone to a little town or wherever and sitting outside eating at a restaurant and you start smelling sewage? You don't really want to go back there, right? And most likely you'll be telling your friends and family about that, and they won't go there. So you have a loss of revenue for tourism and commercial value. People in your area will be getting sick because there's sewer everywhere. So you'll have a lost productivity, and people have to go to the doctor more often, so that increases your medical costs, and which could increase everybody's overall insurance costs. So it all kind of goes hand in hand. Keeping the stuff out of the environment is better for everybody. Now, as far as your system yourself around your home or around your business, your on-site sewage treatment system, if you maintain it, you won't have smells, you won't have backups. There won't be standing wastewater above the drain fields. You'll have a better environmental condition around your house. So the plants and animals are okay. You're not getting sick. Your overall quality of life will be better because you're not having to go outside and smell that. Your kids aren't playing in the ditches and playing in it and tracking it back in the house, getting sick and bringing the sickness to you and everybody else. All these things go hand in hand. And just like we know we have to change the oil in our car, maintain our vehicles, otherwise they'll break down. Well, same thing with sewage treatment systems. If you don't maintain them, you're going to have to fix them eventually. It's always cheaper to maintain them than it is to repair them. And then when it comes down to it, this really is a public health issue. If you're not taking care of your system and it's discharging raw sewage you're making people sick, eventually somebody like DEQ or the Department of Health is going to come in and make you take care of it. So what we say, it's a self-management versus an enforcement issue. It's got to be done. Quite frankly, it has to, because we all need to have clean water. So that's basically what I had. This is a review, and if you have any questions, I think we're going to save those till after Tamika does some talking. We defined sewage and individual sewage treatment systems, went through some maintenance and regulations, and then we talked about the environmental and the health effects of them, and then how to identify system failures, and what are the benefits of maintenance, both for the environment and for you yourself locally around your house or your business.